Our next shortcut is quotients. So when we have quotients, we're talking about when two things are being divided. So one way is to rewrite it in polynomial form, of course. So if I divide each of those terms by x squared, I would get f of x equals 2x. This pen's not that great. Minus 3 plus 2 over x squared, which is going to be 2x to the negative 2. I'm changing pens. And then we can take the derivative of it. Derivative is going to be 2, goes away, negative 4, x to the negative 3. Now, to be able to do our comparison, I need to clean this up a little bit. That's really 2 minus 4 over x cubed. I can make myself have the same denominator. So I could combine them into one single fraction and get 2x cubed minus 4 over x cubed. Now, so Leibniz published the proof on the product rule. Isaac Newton published a proof on the quotient rule. So if I have a function, let's call it h of x, and it's f of x over g of x, then h prime of x is going to be the derivative of the first times the denominator minus the first just like it was times the derivative of the denominator. Notice how similar that is to product rule, but with the minus. But then it has one more thing. We're going to take that denominator, g of x, and square it. Let's try it on the same one we just had. So if I try this, f prime is going to be the derivative of the numerator is going to be 6x squared minus 6x times the denominator just like it is, minus the numerator just like he was, times the derivative of the denominator, all over the denominator squared. Now, normally we could just kind of leave that or plug in from there, but if we're comparing this to what we did in the first step, I need to clean this up. So let's distribute. I'll get 6x to the fourth minus 6x cubed. This is going to be, that's like a negative 1. So it's going to be negative 4x to the fourth. It's going to end up being a plus this time, because negative times a negative. 3 times 2 is 6. That'll be x cubed. It's going to end up being a minus 4x. All over x to the fourth. Well, that doesn't match yet. Let's see if we can clean it up a little bit more. What if we combine like terms? 6x to the fourth minus 4x to the fourth is going to give me 2x to the fourths. Ooh. And then I have minus 4x over x to the fourth. Now notice both of those have x's. So I'm going to factor out an x. And then I can factor out an x out of x to the 4th. Now these x's can divide out. And we're left with 2x cubed minus 4 over x cubed. How can we apply this? Well, here we have a rational function, and we want to find the equation of the tangent line when x equals -2. So the first thing we'll need is a point. We need to find g of -2. So we need to plug -2 into this function. It's going to be -2 plus 3 in the denominator. -4 minus 1 is -5. Over 1 is -5. So just a reminder, that means my point is g of -2 equals -5. That's my x, that's my y. To find the slope, I need to find g prime. The derivative of the first times the denominator minus the numerator times the derivative of the denominator, all over the denominator squared. So I'm going to plug in -2. So when I plug in -2 here, I'm just going to get 1. So that's 2 times 1 minus, that's a -5, times 1. I don't need to write that. In the denominator, that's going to be a 1 squared. So that's 2 plus 5. That's 7. So y plus 5 equals 7 times x plus 2. Wait, I thought we were doing quotients, and all I see here are tangent, cotangent, secant, cosecant. Oh, yeah, tangent is sine over cosine. Now I can find the derivative of tangent. Interesting. F prime of theta equals the derivative of the numerator, which is going to be cosine, times the denominator, minus the numerator just like it is, times the derivative of the denominator, over the denominator squared. So I end up with cosine squared plus sine squared which, oh, that's just 1 over cosine squared. And 1 over cosine is secant, so that means the derivative of tangent is secant squared. That'd be a good one to know. What about cotangent? Well, cotangent is cosine over sine. So same game. Quotient rule. Derivative of the numerator times the denominator minus the numerator times the derivative of the denominator over the denominator squared. Gosh, this is looking so familiar. That's negative sine squared minus cosine squared, which is almost like sine squared plus cosine squared, except for the opposite sign. So that's really negative 1 over sine squared. Which means that's negative cosecant squared. Could I do the same type of thing for secant? Well, sure. Let's write secant as 1 over cosine. The derivative of the numerator is 0 times the denominator just like it is, minus the numerator times the derivative of the denominator over the denominator squared. Well, that's just 0. So now I've got positive sine theta over cosine squared, which is okay, but couldn't I write that as 1 over cosine times sine over cosine? Yeah. And 1 over cosine is secant, and that's just tangent. And we could do the same thing for cosecant and so forth. And we could even apply the rules to some of the same things we've done before. Actually, yeah, I want you to go ahead and practice the rest of them on the next couple of pages. And then we'll go over questions on those in class.